So we continue the chapter current electricity, and now we are coming to the point where we need to understand certain symbols used in the circuit. So symbols used in a circuit, an electric circuit has different electric components connected to the current source. Figure 9.2 shows some of the electrical components which are used in an electric circuit in the laboratory. The symbols and the functions of various electric components are given below. Now they have given you over here certain kind of devices like the Lechaussee cells, the Daniell cell, the storage cell, plug key, rheostat, resistance box, emitter, voltmeter, galvanometer. These are the different instruments or the devices which are used during a formation of an electrical circuit. But ये चीज जो है, when you are drawing an electric circuit, you are not going to draw this rheostat completely, or a battery completely, or a storage battery completely, or a plug key completely. You are going to use a symbol of that thing. So we are now going to see what are the symbols used over there. So we'll start first of all with the different symbols which are used for the power sources, the sources of power. There are two types of current sources: alternating current AC source, such as the mains or in our house and AC generator, and the direct current DC source, such as the cell or a battery. The purpose of the source of current is to supply electric current in a circuit. In laboratory, Lechaussee cells, Daniell cells, and lead accumulators, storage cells are used. A DC source cell is represented by two vertical lines of unequal lengths, and the longer one is marked positive to represent anode, while the shorter one is marked negative to represent cathode. When current is drawn from the cell, it flows from the positive terminal to the negative terminal to the external circuit, and from the negative terminal to the positive terminal inside the cell through its electrolyte, so as to maintain a continuous flow. When a strong current is needed, either we join a number of cells together in series, cathode of one cell connected to the anode of another to form a battery, or we use a storage cell. Figure 9.3 represents the battery, so a symbol of a battery using three cells. In alternating current AC source, mainly it represents the sine curve minus, which is a circle as shown in figure. So now we see the source. So for the source of the thing, we see the first thing is going to be the cell. So the cell will be a simple thing like this, wherein you have got this is the positive terminal, this is the negative terminal over here like this. So this is a cell where the bigger line stands for anode and the smaller line stands for cathode. So that is, cathode is negative charge terminal of the battery and anode is positive terminal of the battery. Now if I want more current, then I am going to use multiple cells together, or I will use a storage cell which is given by the name battery. So when it is a battery, it means there are multiple cells connected together in series. That means इसका anode, इसका cathode, इसके anode के साथ ऐसे करके connected है, and these are connected to each other like this. So this is how they are connected, this being positive, this being negative. This is the battery. And if it is the supply that we are using at our household thing, the plug point wala jo hai, we call it as AC source, or we call it as mains. Okay, and this are DC. This is the DC source. This is the DC source. So these two are DC, but this is AC source, which is given by a circle with a sine curve inside. So that will be a sine wave inside. You can put it this way or this way. Doesn't matter, उससे कुछ फर्क नहीं पड़ता है. It is basically a sine wave which will be a sleeping S inside the circle. So that is called as the AC source. The next we see is the key. Key is nothing but the switch. It is used to put the current on and off in the circuit. It may be either a plug key, a switch, or a tapping key. 9.4 shows the symbolic representation of the keys when they are open and when they are closed. A key is usually represented by the symbol K. In laboratory, generally we use a plug key shown in figure 9.2d. When key is open, the plug is taken out, the circuit is incomplete and is called as open circuit. When the key is closed, the plug is put in, the current flows to the circuit and is said to be as closed. A tapping key is used when current is momentarily needed in the circuit. So this is a time of a key. So first thing is the key or the switch is, first one is a plug key. Now in a plug key, you have got a bracket like this. So this is the plug and this is off condition. Now the same one, if it is like this and a plug is placed inside, then it is on position. Okay, on off, or you can call this as open circuit and this is closed circuit. Okay, this is open, that means the current is not flowing through it. This is a closed, that's why current is flowing through it. The same one, next one will be a switch. A switch will be here. This is also given as K. Now this will be something like this, which is an open one, and if it is a closed one, it will be like this. So this is a closed one. This is closed. Okay, these are also given by the letter K. So this is a normal switch which we all normally use in our houses. These are such kind of switches, taps. Now if you see a bell का कभी हम लोग बटन दबाते तो कहते हैं बटन दबाया and it release अपने आप से. Okay, it doesn't keep it pressed. You know, it is going to come back to its original point. This is called as a tapping key. So this is used when you want the current to be flowing momentarily. So that is called as a tapping key. So a tapping key, it will be like this, that there will be a arrow like this. So this is the tap which is going to be connected. So K here. So this is not connected when it is open, and the same one when it is touching the thing over here, then it is called as closed. So open, closed, tap key. So tapping key, open key, closed key. So these are the different kinds of keys or the switches which you are having in case of the electrical circuits. The next we have is the resistance wire, resistance box, rheostat or variable resistance. See, resistance is something which is going to obstruct the flow of current. So the resistances could be of many kinds. Some resistance would be of the standard value. ठीक है, वो ये resistance जो है वो standard value resistance wire है, तो it is going to have a standard value over there. It could be one which is either variable resistance box जैसा रहेगा, तो उस box में क्या रहेगा कि you can keep it 5 also, 10 also, 15 also, 20 also. There will be different connections over there. So depending upon what connection you are making, it will be having the resistance over there. The third one is a rheostat. Now rheostat or a variable resistance is the one in which there will be a kind of a cylindrical thing. So it will be a cylindrical thing wherein the wires are connected over here, and this is one end, this is another end, and then there is another end, third end over here, which is called as a jockey. So what happens when you connect it to A and then you connect this circuit to B over here, means instead of connecting here, if you connect it over here, then what happens is that as you move this across the cylinder, the resistance will keep on decreasing as based on the movement. तो जितना दूर रखेंगे उतना ही resistance increase होगा. If I connect it here, it will be a fixed resistance from here to here. But if I put it over here, then the resistance is only this much. If I put it here, then the resistance is this much. If I put it here, the resistance is only this much. So I can vary the resistance. That's why it is called as a variable resistance. Rheostat is also called as a variable resistance because of this particular reason, that it can change the value. You can change the values of the resistances which are over here. So that's why we take the resistance. Now resistance again over here will be given in this form. So resistance will be, first one will be fixed one. So fixed resistance will be just a normal thing like this. So there will be this zigzag line which will be there, which will be giving here. So this is the 2 points A and B. This is called as the fixed resistance. And in case of variable resistance, the variable resistance can be connected this way. So there will be this particular kind of resistance, and then there will be this jockey. So if you connect from here A and C here, then this is the resistance what we are talking about. And if you are connecting it this way, that the connection is made not at A, but it is connected over here, C and B. So then it is going to be this much is the resistance which we are talking about. We are talking about this much resistance. So they are shown over here in the textbook with the red color. So then the resistance will be BC. So resistance wire, resistance box, rheostat or variable resistance. A resistance wire is generally made up of alloy called manganese. Now why it is used? Because manganese is basically a wire which is a combination of copper, manganese and nickel. So copper, manganese and nickel, they are going to form into an alloy to give you manganese. Now the advantage of using a manganese rather than just copper is that copper ka resistance is going to change with the temperature changes, but in case of manganese there will not be any change in the resistance of the wire even at different temperatures because of its property of an alloy. So yeah, so we have over here that it is called a fixed resistance depending on the length and thickness. It is used as a standard resistance. A rheostat is a device by which resistance in a circuit can be varied continuously. It is used to adjust the magnitude of the current in a circuit by changing the length of the wire, resistance wire included in the circuit. As shown in the figure 9.5, it consists of an enameled constant wire. Enameled is the insulated, okay, enameled constant wire wound in a form of a coil over an asbestos pipe fitted in an iron frame and provided with a sliding contact jockey on the brass rod. It has three terminals A, B and C, out of which two terminals A and B are the ends of the resistance wire and the third terminal C is at the end of the brass rod connecting the jockey. The enamel of the coil wire is removed at the place where jockey touches the wire. So basically whenever it is completely enameled so that it is insulated, but where the jockey touches the wire at that area, that will be completely non-enameled so that the resistance can be felt over there. The wire between the two terminals A and B provide a fixed resistance equal to the resistance of the entire length of the wire when rheostat is used as a fixed resistance R. Connections are made with the terminals A and B as shown in the figure. The resistance R is used for the resistance. So in case I connect this directly, so A and B directly, then this is the resistance R which is going to be there over here. Whereas in this case, this will be the rheostatic value RH and here this will be the rheostatic value RH. The main use of a rheostat is as a smoothly varying resistance. For this, connections are made between the terminal C and either of the terminals A or B at the end, as shown in the figure 9.6b. The jockey connected to the middle terminal C can be slided and by making its contact at different points, a variable resistance can be obtained. The current then enters at a positive terminal A or B. It flows in the resistance wire of the length up to the jockey and then leaves at the terminal C. So that's why it will be either AC as the resistance or BC as the resistance. So accordingly, depending upon where the rheostat ka jockey is placed and depending upon where the A connection or B connection is made to the circuit, it will give you a variable resistance. The rheostat provides a continuous varying circuit resistance to adjust current of a desired value in the circuit. Symbol RH is used for the variable resistance. A resistance box is provided with several standard resistance, say 1, 2, 2, 5, 10, 20, 20, 50 ohms, connected in series between the two terminals. A resistance of any desired value between 1 ohm to a maximum maximum value, sum of all the resistance can be used in step of 1 ohm by taking out the plugs of the particular resistance of the resistance box. So basically it will be a resistance of 1 ohm, 2 ohm, 2 ohm, 5 ohm, फिर दूसरा 10 ohm, 20 का 2, फिर 50. Why is it so? So suppose the total, if I want to get like say I want 32 ohms, then what I'll do, I'll remove all the plugs, put a plug in 10, put a plug in 20 and put a plug in 2. So that's why it will be 10 plus 20 plus 2, 32. Okay. अगर मुझे समझो 52 चाहिए, तो I'll put another 20 and then automatically do 20, 20, 10 and then 2. So ऐसे करके I can find out, I can get the required value of the resistance by the resistance box. The fourth one is the emitter. So the fourth one, this is the third thing, this is the second one. The first one of course was the power supply. The fourth one is emitter. Emitter is a device which is used to find out the current of the circuit. The current of the circuit is going to be measured by using an emitter. Emitter is always connected in series to the circuit. What do you mean by series to the circuit? Suppose these are the three kind of devices. Suppose ये positive terminal, ये negative terminal, ये positive terminal, ये negative terminal, ये positive terminal, ये negative terminal. If I connect the positive of this with the negative of this, positive of this with the negative of this, in such a case, the circuit which I have made is a series circuit. Means positive, negative, positive, negative, positive, negative, positive, इस तरह से. But suppose I connect all the positives together and I took all the negatives together और इस तरह से उसका connection किया है इस तरह से, then they are called as parallel circuit. So the circuit, the emitter is always connected in series. So अगर समझे ये वायर है तो ये बीच में emitter है और वो ऐसे वायर के बीच में connect होगा. An emitter is an instrument used to measure the magnitude of current flowing in the circuit. It is joined in series in a circuit so that the entire current of the circuit passes through it. It is symbolically represented by the letter A enclosed in a circle as shown in the figure 9.7. The positive sign marked at one end of it indicates the current must enter it through this terminal. Therefore, this terminal is connected to the higher potential terminal of the current source. An emitter must have a very low resistance so that the resistance of the circuit or the current of to be measured may not alter when it is joined in the circuit. It has a dial on which the deflection of the needle shows the magnitude of the current flowing in the circuit. So it has got a dial, so it will be like this, that ये एक box रहेगा जिसके अंदर एक circle रहेगा and then there will be 1, 2, 3, 4 marked over here and then there will be the mark arrow. So this will be deflected like this to indicate what is the current present in the circuit. Different kinds of emitter are required to measure the alternating current and direct current. So if I want to use the emitter for measuring the alternating current, then the emitter will be different. It will be, whereas if I want to measure the direct current, then the emitter will be different. But mainly it is called as an emitter, but one which is going to be showing the current flowing through the circuit. The next what we have is the voltmeter. So the next one is voltmeter. Voltmeter is the one which is going to be measuring the potential difference across the terminals over here. So when you want to find out what is the potential difference between the 2 points of a circuit, then we are going to connect it to a voltmeter. So in that way, the voltmeter is always connected in parallel. So अगर ये circuit है, this circuit and this is the voltmeter, it will be connected like this. So it will be connected here and here. So if this is a bulb over here, suppose there is a bulb over here, so ये bulb के यहाँ से ये वाली इधर और sorry, this one and this one are going to be connected over here, so that the voltmeter will show what is the potential difference or the voltage passing through the bulb across the bulb. So voltmeter shown in the figure 9.2H is used to measure the potential difference between the 2 points of a circuit. It is connected across the 2 points between which potential is to be measured, that is in a parallel flow of current. It is symbolically represented by the letter V enclosed in a circle as shown in the figure 9.8. The positive sign marked at one terminal of it indicates that current must enter it through this terminal. Therefore, this terminal is connected to the point at higher potential. A voltmeter usually has a very high resistance so that it does not draw an appreciable current from the circuit. It has a dial on which deflection of the needle shows the potential difference across the point of a circuit is in between which voltmeter is connected. Different kind of voltmeter are required for measurement of alternating and direct potential difference. The last one, the sixth one over here is the galvanometer. So galvanometer. Now galvanometer actually is a device which is going to tell us the direction of the flow of current. So there is no positive negative in case of a galvanometer because it is just going to show us the deflection. कि अगर current ऐसा जाएगा तो deflection ऐसा जाएगा, current ऐसा जाता रहेगा तो deflection ऐसा जाएगा, right? So it is just going to indicate that what is the direction of the flow of current, or you can say whether the current is flowing or not. So a galvanometer is used when we want to detect the presence of weak current in an electric circuit, or to know only the direction of the flow of current in a circuit. It does not measure the magnitude of the current in a circuit. It is joined in a circuit in series just as an ammeter. So of course this is also connected in series because it is going to see whether the current is flowing or not. So current के जैसे ammeter जैसे हम लोग connect करते हैं, उसी तरह से galvanometer also will be connected in series in the circuit. It is symbolically represented by the letter G enclosed in a circle as shown in the figure 9.9. Current can enter or leave through any of its terminals. Therefore, no positive negative signs are marked at its terminals. It has a dial with zero mark at the center. The deflection of needles on it shows the presence of current, and the direction of deflection indicate the direction of the flow of current. So the point is always like this, the needle is always like this with zero over here. If the direction is this way, it will deflect this way. If the direction is this way, it will deflect this way. There are also markings over here and markings over here to tell you that how weak and how strong is the current. So the deflection more means more current, deflection less means lesser current. So अगर ये side पे deflection ज़्यादा है यानी direction is this way and it is more current. The deflection is very less over here, that means that the direction is this one but the current is less. The next one is the load. So what we have next is called as the seventh one is the load. Load could be a simple bulb or a resistance. So normally over here they are given as the bulb. So it is this way. And in case of it can also be a heater. So it will be a heater which will be called like this. So this is a bulb and this is the heater. Okay. So a load, an appliance which is connected in a circuit is called as a load. It may be just a resistance, a bulb, a heater, etc., or a combination of different electrical components. It can be represented by the symbol L as shown in figure 9.10. And finally are the connecting wires. So connecting wires are, suppose ये दोनों के बीच में connect किया तो ये है connecting wire. Okay, so if I am connecting this to this, so here this is the connecting wire. Okay, if I connect this to this, then this is the connecting wire. So the red color line what I am showing over here, it's just the connecting wire. So these are the wires used to connect various electrical components. They are made of highly conducting metal such as copper or aluminum because of its low cost. Normally we use copper, but sometimes if it is too long a distance, it will be aluminum wires to be used because of the low cost. So that they have a negligible resistance and do not change the resistance of the circuit. A connecting wire may be a thick wire or several fine wires twisted together. Generally, we use thick insulated copper wire as a connecting wire, which is represented in a circuit diagram simply by a line. So this was about the different kinds of the devices or the symbols which are using for the electric circuit. Now we see that a simple electric circuit. So in a simple electric circuit, in our daily life we use a torch in which a cell, a combination of two or more cells, is connected to a bulb. This is the simplest circuit, electric circuit, which uses only three components: a cell, a switch, a bulb. Figure 9.11 shows a line diagram representing the simple electric circuit containing a cell, a bulb and a switch. As the switch is closed, the current flows through the bulb and the bulb glows. The flow of the current stops as the switch is opened. The bulb then ceases to glow. Figure 9.1 to illustrate another simple electric circuit in which various components are the cell, key, rheostat, bulb, voltmeter and emitter. Here the bulb acts as a load. It is clear that the emitter, cell, key and rheostat are in series with the bulb, while voltmeter is connected in parallel across the bulb. So that's what they are shown over here, that if I draw a circuit, so if I am using the different things what we learned in a circuit diagram, so we have over here that there will be a particular kind of a cell. So this will be a positive and negative terminal of the cell. The cell is then connected to a key which is closed, and then it is connected to a rheostat. Now the rheostat ka jo jockey hai, it is connected to some another part over here. It is connected over here to a so we have an emitter here. So this positive, the negative of the term emitter, and then this is connected to a bulb like this. So you can see that when I change, now I want to check what is the voltage over here. So that's why I'm going to connect over here the voltmeter like this. So the voltmeter is going to measure the voltage across the bulb. Emitter is going to measure the current which is going through the circuit. Key is going to open and close the circuit. Rheostat is going to increase and decrease the resistance. As I increase and decrease the resistance, the glow of this bulb is going to increase and decrease. So that is what is the setup of the circuit diagram. To demonstrate the function of various components of the circuit as shown in figure 9.12, first take out the plug from the key. This makes the circuit incomplete or open circuit. The bulb does not glow and both the emitter and voltmeter read 0 since no current flows in the circuit. Now insert the plug in the key. The circuit is complete or closed. The bulb glows and the emitter reads current in the circuit, while the voltmeter reads potential difference or voltage across the bulb. Then vary the resistance of the circuit by sliding the variable terminal of the jockey or the rheostat. The glow of the bulb changes as well as the reading of the emitter and voltmeter changes. On decreasing the resistance by sliding the jockey to the left, the glow of the bulb increases and the reading of the voltmeter also increases. So the increase in the resistance by sliding the jockey to the right, the glow of the bulb decreases and the reading of the emitter and voltmeter also decreases. So that was about the circuit. Now we see about insulators and conductors. The substance which do not allow the current, okay, so this is an insulator. Why? It's plastic. It doesn't allow the electricity to pass through them because it doesn't have free electrons. So these are insulators. So substances which do not allow the current to flow through them are called insulators. They almost have no free electrons and they offer a very high resistance in the path of current. Some examples of insulators are cotton, rubber, plastic, wood, paper, glass, leather, pure water, asbestos, china clay, etc. Conductors, the substance which allow the current to flow through them easily are called as conductors. All metals such as copper, aluminium, silver, iron, brass and steel are conductors. They have a large number of free electrons and they offer a very small resistance in the path of the current. The human body also allows the current to flow through it, so it is a good conductor. The impure water, that is acidated water or tap water, and mercury are also conductors of electricity. Now we talk about closed and open circuit. So a closed circuit is one which is allowing the complete circuit to flow through right from the battery to the circuit and back to the battery. So वो पूरा का पूरा अभी closed है, so it is closed circuit. And when it is stopping at some point due to some some non-conductor in between, then it will be as a open circuit. So the path along which current flows is called as a circuit. The current flows only in the circuit is complete or closed. If the circuit is open or incomplete, the current doesn't flow. For electric circuit to be complete, each component of it must pass current through it. That is, it should be conducting. If there is an insulator in the path or if the circuit is broken, the circuit is incomplete or open and the current will not flow through it. Figure 9.13, a bulb is connected between two terminals A and B of a dry cells by two metal wires. The circuit is complete and the bulb glows. Because metal wires here, so both are conductors, that's why the bulb glows in condition A. In condition B, you can see the metal wire is broken from point A side. Point A side mein wire is broken, so it's an open circuit. So you can given that in figure B, the circuit was from one terminal A of the bulb of the cell of the bulb is broken. So the circuit is incomplete and the bulb does not glow. In figure 9.13c, one terminal of the cell is connected to the bulb while a wire, while the other terminal B of the wire is connected to the bulb through a thread, which is the insulator, because the thread is not a conducting wire. So that's why, because it's just a thread which is insulator, that's why the bulb will not glow. So the circuit is incomplete and the bulb does not glow. So this is the example of very silly and easy thing about open and closed circuit. So that was about the end of the first part of the chapter. We'll now move on to the next part of the chapter in the next video.